So let's look at this example. A boat company claims that the mean weight of men is 166.3 pounds if we take a random sample of 40 men and find that the mean of those 40 men is 172.55 pounds with a standard deviation of 26.33 pounds. Test the boat company's claim. So first of all, just like with the testing a claim about a proportion, we'll identify the claim, but of course this time we're not testing a proportion, we're testing a claim about a mean. So the claim was that the mean weight of men is 166.3 pounds. So that is, the mu will equal 166.3. And the opposite then is not equals, so the mean does not equal 166.3. Step 3, just like before, is identify the null and alternative hypothesis. And again, since the equal sign in this case is with the claim, the null hypothesis will go along with the claim, and the alternative hypothesis will go along with the opposite. Since the alternative hypothesis has a not equals, we know that this is a two-tailed test. So now let's calculate the test statistic using this test statistic formula, where in this case x bar is the 172.55 pounds, and our mean, population mean rather, is 166.3 pounds. S in this case, our sample standard deviation, was 26.33 of a pound, and our n, of course, was 40 since we sampled 40 men. So throwing all this into the formula, we get a test statistic of about 1.501. So notice I'm taking this out to 3 decimal places now, mainly because the distribution sheet that we have for t-distribution, all those t-scores have 3 decimal places. So I'm just being consistent with those. But if you took it out to 2 decimal places or 4 decimal places, that's fine. So next we'll find the p-value with the student t-distribution table. You can also find the p-value with Excel if you want to know the exact p-value. But in this, we can find just an estimate of the p-value using the t-distribution table, which is good enough if we're just comparing it to find out if it's less than or greater than the significance level, because that'll tell us whether to reject or fail to reject the null hypothesis. And that's all we really need. So since our test statistic is positive 1.501, and we want the area to the right of our test statistic. And since it's 2 tails, we're going to look up the area in 2 rows, or excuse me, in 2 tails row on the t-distribution table. So that is, I want to first find my degrees of freedom, which since we were our sample size was 40, I'm going to go to the row 39 and look up 1.501 in that row. But of course, notice 1.501 is not in there. But 1.501 is between 1.685 and 1.304. So in the area in 2 tails, that tells me my p-value is between 0.1 and 0.2. So I know my p-value is between 0.1 and 0.2. Now I just have to compare this to my significance level to decide whether or not we reject the null hypothesis or fail to reject the null hypothesis. So since our p-value is greater than 0.1, we know it's greater than our significance level of 0.05. Now you may be asking, why did we use 0.05 for the significance level? Well, the idea is that if you're not given a significance level in the original problem, 0.05 is the most common significance level, so we're just going to use that as a default. So because we know our p-value is between 0.1 and 0.2, we know it's greater than 0.1. And if it's greater than 0.1, it is certainly greater than 0.05, and since the p-value is greater than our significance level, 0.05, we fail to reject the null hypothesis. So now interpreting that result, let's look back at the original stuff we did, identifying the claim. Since we failed to reject the null hypothesis, let me cross out my alternative, which went along with the opposite, and that means we can indeed support the claim. So my interpretation is that there appears to be enough evidence to support the claim that the mean weight of men is 166.3 pounds.